do you think Unity or Unreal would be better for a newbie for an SLP? I feel like Unity is a quicker quicker learning curve to get something up and running that you can work with. I don't have a lot of experience with either. Unreal gets you some things up pretty quickly, but to be able to actually go in and make changes and know what you're doing feels like a pretty steep learning curve to me. And Unity, I think, is really geared towards quick entry. And yeah, different languages, so C++ or C#. But you know, not a bad proposition to download both and go through some of the tutorials and see what works for you. That's a reasonable way to spend some time on your SLP for fall term, is doing that sort of exploration. Cool. All right. Let's see. Send me an attendance ping. Let me know you're here. So let me start off looking at ODP 409. So this was your square root program that that takes a command line argument, calculates a square root, prints it out, but also does some error checking. And the order in which you do error checking is really critical, right? Suppose you're working at a club and your job is to only let certain people into the club. So they have to be members and they have to satisfy a dress code, right? So what do? First you look to see if there's somebody at the door, right? You're not going to check to see if somebody's a member if there's nobody at the door, because people are going to think you're talking to yourself and you're probably going to get fired, right? So before you look to see if there's you know, if the person at the door is a member, you want to know, is there somebody at the door, right? You can't just you know, run somebody's ID through a membership check if there's nobody standing there, right? So what does that mean for 409? Before you check to see if there's a valid argument, is there an argument at all, right? So let's sketch some of this out. So is there exactly one command line argument? And if not, that's just an error. You're done. If there's nobody at the door, I'm not going to check IDs. I'm not going to check their dress code. I'm going to have to make sure that they have shiny shoes. I'm not going to do anything, right? There's nobody at the door. All right? But if there is somebody at the door, now we can you know, start to say, is this, well, okay, so the analogy will break down here, but if we have a number, if we have an argument on the command line, is it a number, right? If it's not a number, how can I check to see if it's negative, right? If it's not a number, how could I print its square root? So once we've decided there is exactly one argument, right? Now we're going to check to see if it's a valid number. So how do we do that? That's where we use scanf. So our next check is the argument a valid double? And so we do the scanf thing. We have our %lf followed by a %s, so we can pick up extra things after a double. And you know, if it's not a valid double, we just say invalid and we exit. So I'll just say return to say we're just going to return from our program. But if there is exactly one argument and it is exactly a valid double precision number, now we can check to see if it's negative. And so we can say is the valid argument negative. And if it is, then we print negative and we return. But if we get through that check, and that check, now we can print the square root of whatever the argument was. Chat question, will you be reviewing ODP source code sometime during the quarter? So what does that question mean, hand reviewing? So if yeah, go ahead, expand on that. So if there's a question about it, like if your code worked, and you feel like you should have gotten credit but you didn't, right? I can look at the source code with you and so on. You don't need to put the ODPs into Git. You're welcome to, and it's good practice with putting things in Git and so on and so forth. But I'm not requiring you to put those into Git, and I'm not planning on looking through that stuff. But like I say, it's good practice to put it in there, and if you want to go back and refer to your ODPs later on, right, you've got them in one place. And you could even do things like copy the README from /tmp, put that in your ODP directory, and then if you push all of that to Git, you've got a nice resource there, and 73 years from now, if you're trying to remember how to scan a double and pick up extra stuff, you can say, oh yeah, I had an ODP for that way back in 2021. And you can go back to GitLab and get your code back. So that's a reason. But no, I'm not planning to go through it per se. All right. So here's some pseudocode for how we can do ODP 409, right? Is there exactly one command line argument? If not, it's an error. If there is it a valid double? If not, it's invalid. If it's valid, is it negative? If it is, print negative. Otherwise, go ahead and print the square root. And when we convert this into C, we're going to write a series of if statements for each of these checks, and our if statements usually look like if some condition, curly bracket, and then we have stuff to do if the condition is true. And then we can put an else and say, stuff to do if the condition is false. But if we can avoid having to write if else, if else, if else, and nesting things and all that kind of stuff, our code will be a little simpler. So when choosing what kind of condition to test for, sometimes it's nice to say, hey, whatever stuff we want to do if the condition is true, let's make this condition something so that if it's true, we do this stuff that's listed inside the curly brackets. So I wrote this as, is there exactly one command line argument? And if not, if this is false, then I want to go ahead and print an error. So let me try to rewrite this in a different way. Is the number of command line arguments different from 1? Sorry, different from 2. And if yes, then we're going to print out error and we're going to return. And why am I looking to see if it's different from 2? Because if I say ODP 409 and I put, a number, argc is going to be equal to 2, 1, 2. If I just say ODP 409, argc is going to be equal to 1. If I say ODP 409 and I put a number and maybe I put another number on there, argc would be equal to 3. 1, 2, 3. So the case I'm interested in exploring further is where I have ODP 409 and one thing specified after that, and in that case argc is 2. So my check here is the number of command line arguments different from 2? Right, where here I'm just going to check argc. So if argc is different from 2, I'll print error and I'll return. And if I'm going to return, I'm not going to go on to the rest of the code, so I don't need to say else. The only time I'm going to get here is if this condition failed. So now, is the argument a valid double? Well, if I want to change this into some condition where if the answer is yes, I want to print out invalid, I can do the following. Is argument not a valid double? And if that's true, I'm going to print out invalid, and I'm going to return. And again, since I'm returning, I don't need an else statement here. I can go on to my third one. And here I already wrote a condition that if it's true, I want to print out my error messages. So is the argument negative? So is the argument negative? And if it is, then I'm going to print out the word negative, and I'm going to return. And I still don't need an else, because I know if I got here, this failed, this failed, this failed, I've got a valid argument, it's a double, and it's not negative, so now I can print the square root of my argument. And I'm done. Let's see, I had a hard time determining if it was better to use if-else or use a switch case, which was best for this. Switch case would work well for this problem as well, but is mostly personal taste. Yeah, so we have some freedom when we're writing code, how we want to describe our intention to the computer. So a switch statement is usually used when you have an integer or a character maybe, and you're trying to enumerate multiple possibilities. Testing the number of command line arguments, testing the return value from scanf, testing how a number compares to 0, those are three kind of sort of different flavors of conditions. Might not be very, very directly mapped into a switch statement. Now, if this was something like, if there's 2 command line arguments, if there's 3 command line arguments, if there's 4 command line arguments, that's a perfect setup for a switch. You could do a switch on the number of command line arguments, and you could say, case 2, do this, case 3, do that, case 4, do something else. But for this one, you could do ifs or if-elses. And there's nothing wrong with else's, but if you can do something like, if some condition, do this and return, when you return, you're never going to go past that closing curly bracket. And so I don't really need to put this in an else. I could, it might be clearer, but if I put this in an else, there's a possibility the entire rest of my program is going to be indented inside an else. And it can be just a little harder to read sometimes, but definitely personal taste. All right, so how do we map this into a C program? Is the number of command line arguments different from 2? So supposing that you wrote this as a pair of arguments, so argc and argv, and you should call these argc, argv. Doesn't matter what they're called, but it's absolutely conventional. It's been conventional for almost half a century to call this argc and this argv. If you want to be alternative, you could call them A and B, right? And if that works well with whoever's looking with your code, that's good. If you're doing this in a job interview, that's probably not so good, unless they're looking for, someone who's a free thinker. So argc, argv, is the number of command line arguments different from 2? Well, argc is the number of command line arguments. So this first statement is basically if argc is not equal to 2, And in that case, print the error message and return. So I'm mixing in some pseudocode here with C. Right? And that takes care of the whole argc question. And if I type something that has, extra stuff in the beginning, if I type something with 2 numbers, if I type something that doesn't have any command line arguments, argc will be different from 2, and this code is just going to say, hey, you got an error, goodbye. So down here, if I get to this point, I know I have exactly 1 command line argument. Is it not a valid double? So this is where we use our scanf. And the argument is going to be in argv bracket 1. So we'll do our trick that we saw yesterday, where we'll scan into a double, matching a %lf, but we'll pick anything extra that comes after the double, and we'll scan that into this thing called extra. And then how do we know that we got exactly 1 double? Return will be equal to 1. And so what does scanf do? If you have a number like 2.3, this will return a 1. If you have a number like 2.3 ha, this will return a 2. If you have a 2.3.4, this will return a 2. If you have ha, it'll return 0. If you have a totally empty line, it'll return -1. So the condition which says I have a valid double is the return from scanf is 1. Okay, so if it's a valid double, scanf returns 1. If it's valid, then our return will be equal to 1. So if it's not valid, what's the opposite condition to return equals 1? How can we write in C a statement that says return is not equal to 1? It's just return is not equal to 1. Right? That is the way that you negate something in C. So return equals 1, we could check for that as equal equal. Return not equal to 1, we say exclamation mark equal. And that's very different from saying if return equals 2. Because if return equals 2, it means I've got one of these cases. If return equals 0, I've got this case. If return equals -1, I've got this case. But all of these cases, what they have in common is that return is not equal to 1. In this case, return is equal to 1. So that's how I split the universe, right? Valid, not valid. So if return is not equal to 1, we don't have a valid double, I'm going to print out inverse invalid, and I'm going to return. All right, if we get through that, now we're ready to see if our argument is negative. Well, we scanned our number into num, and so we can say if num, and negative means less than 0, not less than -1, less than 0. So if num is less than 0, we'll print negative, and we'll return. And only then, if we get through all 3 of these cases, do we print square root of number and print it with a %lf. Yeah, that's a good line to throw at an employer, definitely. All right, so let's take a look at this. And I'm going through this in detail because probably at least half the class was doing something different from at least some part of this. So I think it's time well spent to really break this down. So here's an implementation of what we just did. So, you know, x is my double, extra is my extra stuff. So first thing I'm doing, see if argc is different from 2. And if it is, print an error message and return. Okay, that's that first part right there. If we come through that, now we can say, you know, let's scan argv1. Let's pick up extra stuff, throw it into extra. Let's save the return value in this variable called flag. And if flag is anything other than 1, it's an invalid input. Doesn't matter if it's 2, 0, -1. If it's anything other than 1, it's invalid. So that's that piece right here. If we make it down to here, what do we know? You had exactly one argument, and it was exactly a valid double. So now we can check to see, is it negative? Well, it got scanned into x, so we can say if x is less than 0, print out negative. And if you make it all the way down to here, you're all good to go. Got one argument, it's a double, it's not negative. Now we can calculate its square root, print that out. So, and don't forget your -lm when you compile. So if I say S1, that's an error. I don't have exactly one argument. If I say S1 2345, that's an error because I have 2 arguments. If I say S1 23, but I have something that's not a valid double, that's invalid. If I have a negative number, that's negative. But if I have a negative number that's not a valid double, that's going to be invalid. It's not even going to check to see if it's negative. How can you check to see if it's negative if it's not a valid number? Right? I mean, maybe this looks negative to us, but, you know, this is not a recognized double precision number. So comparing that to 0 is meaningless. So our earlier check will say that's not valid. It'll print out invalid. And then if everything is valid and everything is good to go, it'll go ahead and print out the square root. Let's see, I had an if-else where the final else was a catch-all for all non-specific errors, including incorrect input. Is this good programming etiquette? Yeah, that's something that sometimes feels better. So if you have a bunch of if-elses, right, you could do, you know, if x is bigger than or equal to 0, print this out, else print out some kind of unknown error. But be a little careful of that. It's probably more ideal if you can be so certain of your logic that you know you've covered all the possible cases. And you can make your final statement sort of a catch-all, right? So if this didn't happen, if that didn't happen, and if this didn't happen, then I'm good to go. I'm going to go ahead and print out the double, the square root of it. But yeah, if you commented thoroughly, as someone just said, then you're probably okay. But, you know, job interview, someone might come back at that and say, you know, could you write this without that final else? And sort of challenge you to modify it. So always try to be as comfortable as you can with the code you're writing. And if you're not, start messing with it, you know. If you're not sure what would happen if you didn't have that else, take it out and try it, explore it, right? The more time you can spend just sort of messing around with your code, the more it's going to demystify it. And, you know, code should be magical to everybody else who looks at it, but to you, you should really understand exactly what it's doing. That's sort of the whole secret to, like, you know, being the worshipped programmer. So let's mess with this a little. suppose I take this and I put it down here. And I saw a lot of code that looked like this morning. Well, you know, it does that correctly. It does that correctly. It does that correctly. It does that correctly. And it does that correctly. But there's one thing it won't handle, which is if I just say S1, I get a seg fault. And you really never want to throw seg faults. That's really saying something happened that my code's not handling. And so why are we getting a seg fault here? We're checking the ID of the person at the door before we've checked to see if there is somebody at the door. That's a seg fault. Right? argv bracket 1 is saying, show me, let's analyze the second element in this argument array. But if somebody just says S1, there is no second element in the argument array. There's only one element in that array, which is S1. So we're trying to look at the second element in this array, and it does not exist. And when we try to look at that and convert it to a double, we throw a seg fault. Seg fault means you're trying to access memory that you don't have access to, possibly because it doesn't exist. In this case, it doesn't exist. Well, how are we supposed to know that there was no argv bracket 1? How are we supposed to know that that did not exist? Because we were supposed to check the value of argc. So if we put this first, right, that will save us from the case where there's only the name of the function and there's no argument given to it. This right here will say error, and we'll exit, and we'll never get to this thing that can potentially throw a seg fault. All right, similarly, suppose we check for a negative as soon as we scan. Well, you know, this works fine. Picks up there's no arguments. This works fine. It picks up there's too many arguments. This works fine. It's not, you know, seeing a number there. But this is doing the wrong thing, right? If we don't have a valid double on our argument, it should print out invalid. But instead, it's printing out negative. And the order that we chose to do these things in is critical, right? If you don't have a valid double, right, you're going to print out invalid and exit. You have to do that before you check to see if your argument is negative. But what are we doing in the code? We're doing our scan, but before we check the return value from that, this flag which tells us whether or not it's valid, we're checking X. Well, if this flag is not exactly equal to 1, we don't really know what's going on with X. If our flag came back with a 0 or a -1, X is effectively random. If flag comes back with a 2, X is, you know, what it got when it tried to convert the beginning of our input, this -2, right? But the fact that flag was equal to 2 says that there was some extra stuff after that. And the specification of the problem says, you know, if they type in a negative number followed by other junk, print out negative. That's not what it says. It says, in effect, if they type in a -2 followed by other junk, print out invalid, because it's not a valid double. So you better do that check before you do this check. And we've broken that, right? We're checking for the negativeness before we check the return value from scanf. So this has got to go right after this. And then when you get through that, you've got an argument, it's a valid double. Now we can check to see if it's negative. And if it is, then we can print out an error message. Otherwise, now and only now can we say, let's calculate the square root and print it out. So order is critical. let's see, my check was if the argument was proper and positive, then calculate. Else, if the argument was negative, print a negative error. And then since all other possibilities, put an else for the others. That might work. And readable, you know, at this stage of things, to me, readable means readable to you. If it makes sense to you, that's a good way to write the code. There's plenty of time down the road where teachers will yell at you because, you know, you should have done it like this, or you indented too many times, or you should have called your variable I instead of J. I'm not going to do that to you, right? If it makes sense to you and it works, right, I'm going to say that's probably a good way to be doing it. Because if you can read your code, you're going to be more successful at debugging it, you know, testing it, modifying it, making changes down the road, and so on. So I would use that as your metric. All right, so let's play with fgets. So I'm going to write some test code here. So let's make an infinite loop here. So I'll just loop while 1 equals 1. And I'll say enter a number. And I'll use fgets to read from standard in. And I'll save the user's input in this variable called temp. And I'm going to convert this to an integer, so the user's input, so I'm going to use scanf. And so I'll save the return value. And I'm just going to go simple today. I'm just going to scan with a %d. I'm not going to worry. Well, no, I'll do this the right way. %d, %s. Let's save that into num, and let's save the extra stuff into extra. So let me put a few variables in here. So temp's going to be my input buffer. Extra is going to be where my extra stuff goes. And num's going to be my integer. All right. So we'll say enter a number. I'll make this look nice. I'm not putting a new line at the end, so it will, it will come out on the same line. I'll read a line of user from the input, and then I'll say let's scan that into an integer and some extra stuff, and I'll save the result in num. And now let's see if we have a valid integer. So if num is not equal to 1, that's an error. And I'll say error, please try again. Else, got a good number. Very good. The square of %d is %d. And I'll print out your number, and I'll print out your number squared. And there's the end of my while loop, and there's the end of my main program. All right, take a look at that for a second. Let me read comments here. Just to review, when scanf writes a value to a variable, it needs to know the pointer to the memory address where the value is held, which the ampersand does, correct. To directly write the memory address. So when the variable is not an array and it's not a pointer, what does that logically mean? So num is just an int. It's not a pointer, right? It's an integer, and so since scanf needs the address of num, I have to put that ampersand in front of this. Now if I don't put that ampersand and I run this code, I'll segfault, because it will think that num is an address and it's really not. But if I declared num to be a pointer to an integer, then I would just say num. I would not put the ampersand in. But if I put integer star num and I ran this code, it would still segfault because I'm telling it that num is a pointer to an integer, but it's really not, right? Just saying integer star num, it says num's going to point to an integer, but I've actually got to make num point to an integer. I've got to tell it where to point. And we're gonna get into that later when we talk all about pointers and memory. But that's basically what's going on right now. 120 says you're allowed to read and store a total of 120 characters in this array. Don't do more than that because I'm telling you I only have space for 120. So it will read up to 119 characters, store those in temp, and then store a null terminator at the end. So that basically, yeah, exactly, makes sure the character buffer isn't overflowed. So scanf is expecting an address, right? In this case, it wants the address of this integer called num. In this case, it wants the address where this array of characters begins. And with arrays, if we just say extra, that's actually the address of the first character. It's not the actual character, it's an address. So we don't put an ampersand there. And for now, that's just something to know and try to keep straight when you use scanf. For integers, doubles, floats, characters, you need an ampersand in front. For arrays, you don't want an ampersand. All right, so if I run this, let me compile it. If I run this, it says enter a number, 23. Oh, I got a problem somewhere besides my typo. This should be if return is not equal to 1. And let me spell error right. All right, so return is the return value from scanf. So that's what I compare to 1 to see if there's an error. So now if I say 23, it says very good. Wow, it's typo city. All right, 23, very good. The square of 23 is 529. Negative 1, good. The square of -1 is 1. Haha, error, please try again. 2.3, error, please try again. So, 7. Very good. The square of 7 is 49. All right. So this is all good, right? So any questions about what we're doing here? And then we're going to break it. And yeah, in answer to the question in chat, if you had a particular address you wanted to save these things in, you could put that address in here, and it's not always going to be ampersand, some variable name. There's other places this could come from. And that is something that you might do sometimes. But probably not so much for 224. All right, so let's look at a different version of this. Let's suppose you're not going to bother with any of this funny stuff with fgets, and we're just going to use scanf. So scanf reads directly from standard in and does this conversion. I'm going to say, don't do this. All right. So why is this a bad thing to do? It's fundamentally the same code, right? The only difference is here I'm doing fgets into an array, and then I'm doing scanf on that array. Whereas in this try bad program, I'm just doing scanf directly from standard in. So let's see what happens. So I say try bad. It says enter a number 2. And what is it doing here? Oh, there's an error. Please enter a number. 2.3. There's an error. Please enter a number. -4. Well, it's just kind of hanging out here waiting. There's an error, right? So something is wonky here, right? Well, what's going on is that scanf is looking for an integer followed by some extra stuff. And if I just type an integer, it says, okay, I got an integer. Where's my extra stuff? And I'm sitting inside the call to scanf waiting for that extra stuff. Well, that's weird. Okay, so we're just not going to worry about this. Let's just get rid of this funny business. And let's just scan an integer, because this is just quick and dirty. I just want to do this, and then I want to go on to lunch, right? So I'm just going to scan with a %d. Well, that's a little better. So if I type in a 2, good, the square is 4. If I type in -4, good, the square is 16. If I type in, 2.3, something happened. And, I can try typing in some numbers here, and, it's doing things. And if I type ha, same thing. It says, error, please try again, enter a number, but it's not letting me enter a number, right? And PA2, I see this. This pops up in people's programs, right? This is the issue with using scanf. And the problem is, so Control-C gets you out of that. So the problem is scanf is doing both ingest and parse. It's trying to read and it's trying to parse. And if I don't have an integer in the beginning of my input line, it does not ingest anything. And the next time I come back up here, it looks and it sees the same haha sitting in my input. It says, oh, I can't scan that. It returns, a 0. I print my error message, come up here, I come back to scanf, it looks, it sees haha. So by doing this, we're ingesting first, and then we're going ahead and we're parsing. And that's going to be like far more useful and far less error prone. So we're always going to want to split those into pieces. All right, so let me take a really quick look at PA2. So PA2 is posted. Yeah, this class goes quickly sometimes. Let's take a look at PA2. So PA2 is a stick picking game. Imagine that. Basically the same thing that you just did, but with a few exceptions. Okay, a few differences. The first difference is this is written in C. Okay, so make a stick.c for your code. You can have other files and so on, but your executable program should be called stick. Okay, the computer always goes first. Don't ask the user anymore who wants to go first. Always have the computer go first. The biggest difference is the user can behave badly, right? So when you ask them how many sticks should they take, they could say haha. They might just hit enter. They might type a 2, a space, and a 3. They might type an invalid number like 0 or 5, right? You got to handle all of these conditions. Okay. The other difference is when you begin the game, there's 2 different ways that the person can say how many sticks they want to play with. They can do what they did in PA1. They can say stick, hit enter, and you can say how many sticks do you want to play with, and they can say 25. But the other option is they can just say stick, space, 25, and that says I want to play the game with 25 sticks. You don't ask them who goes first. You don't ask them how many sticks. You just start playing the game. And the computer goes first. So if I say stick 25, it should show me 25 sticks, and say the computer takes, 1 stick and show me the new pile of sticks and so on. All right, legal game is 20 or more sticks. All right, so you need at least 20, but you can go up to 2 billion. Another difference is if there's any error in choosing the initial number of sticks, print an error message and exit. If I say stick haha, error message and exit. If I say stick 25.2, error message and exit. If I say stick 25 space haha, error message and exit. Right? If I say stick space and an integer, play with that many sticks. If I just say stick, ask me how many sticks. If I say 25, play the game. If I say haha, error message and exit. If I say 25 point, error message and exit. Okay? I really, really, literally mean exactly what it says here. If there's any error in choosing the initial number of sticks, print a message and exit. Right? But the number of sticks can be specified one of two ways. I can use a command line argument, or I can use no command line argument, in which case you ask how many sticks and I type in a number. If I say stick 25x, don't ask me how many sticks. That's an error in the number of sticks. Print an error message and exit. All right. Assuming that the person specified a valid number of sticks, go ahead and play the game just like we did in PA1, with one other notable exception, which is when you ask the user how many sticks, they can make a mistake. They can make a mistake 20 times in a row. Keep asking them. Don't give up. Right? PA1, you gave up after 2 invalid entries. PA2, you keep asking them. So if they just hit enter, if they put in an invalid number, if they put extra stuff after the number, those are all mistakes. Go ahead and ask them again, right? So keep doing that until they enter a valid integer, and then, you know, take that number of sticks off the pile and keep playing the game. And so you definitely want to use fgets and sscanf. Don't use A2I. Don't try to use scanf. Those things will cause you problems. And I will find test cases that will fail if you're doing these things, right? So I'm going to try all these different conditions and probably some other ones, and make sure your code works correctly. And then submission, just make a PA2 directory under CSE224. Put all your work in there, meaning your source program, stick.c, your executable stick, and anything else that you have that needs to be present to compile your program. Make sure all of that's under PA2, push it to GitLab. And again, I suggest pushing it as you go. Let's see, question. I'm also guessing we don't need to display the amount of sticks. So play the game as in PA1. So display the pile of sticks, a series of pipes with no spaces between them, followed immediately by a left parentheses, the actual number of sticks, and a right parentheses, and then a new line. So everything else is exactly like PA1, and I did not rewrite PA1 in here to try to keep this down to a readable size, which is 1 page. You can write multiple functions. That's definitely a good thing to do. That will simplify your coding. All right, send me a parting attendance ping. Let me know you're still here. And again, no classes on Friday. That's a Clark holiday for students tomorrow. So I will see you on Monday. I will have office hours tomorrow. I took it off the calendar for advising, but I will have office hours. If anybody has questions, come in tomorrow at 8:30 and we can talk then. Otherwise, have a good weekend. I will see you on Monday.
Thanks, have a good weekend.
Thanks, you too.
Goodbye.